Good evening, everyone. Welcome to the to week 5 of live sessions for Introduction to Biostatistics. And the course is I am Prashasti Pandey, PhD, PMRF Fellow from Department of Botany, Banaras Hindu University. And I'll be conducting today's live session for the course whose instructor is Professor Shamik Jain from IIT Bombay. And now, as if you have attended the previous live sessions for this course, we will solve certain questions that were there for previous year's assignments. And solving these questions will help you solve this year's questions of the assignments that you are getting. I hope these live sessions will be useful for you. So, the way we'll be going ahead is I'll be displaying a question on your screen with four options, and I'll give you 2-3 minutes of time. If you know the answer, you can either write it in the chat box or you can raise your hand, you can tell the answer. If not, I'll be telling you the answer on the screen and we can move ahead. Okay. So now the first question on your screen is, if three items are taken out randomly from a bag containing 10 distinct items, what are the different combinations of items possible? Your options are 120, 100, 150, and 200. I'll give you 2-3 minutes time. If you know the answer, please go ahead. Otherwise, I'll tell the answer. Okay. So we'll just try to solve this question. So these questions for this session are about probability and the combinations and these kind of questions. So if you look at this question, it is said that there are three items which are taken out randomly from a bag containing 10 distinct items. And it's asking about the different combinations of the items possible. Now, um, let's first understand the basic formula for any kind of combination questions if we have to solve. So combination is usually written in this way, either C, N, comma R, or sometimes it's written like this. Okay, so these are the two ways how you can write the combinations, and the formula will be n factorial divided by r factorial into n minus r factorial, where n is the total number of items and r will be the number of items that are chosen. Okay, so now with the help of this, if we try to solve the question that we were asked, so in this case, your n will be equal to 10 distinct items, okay, and the number of chosen items will be 3. So your R will be 3, okay. So now using the combination formula that we have learned earlier, so your combination for the given N and R value will be your 10 factorial divided by, so your R is 3 here. So 3 factorial into 10 minus 3 factorial. Okay. So now if you just solve it, it's very simple. So you just um, solve this equation. 3 factorial into 10 minus 3 is 7 factorial. Okay. So if you solve this entire equation, you can uh, simplify this. So factorial means you will multiply all the numbers after that. Okay. So it will be 10 into 9 into 8 into 7 factorial divided by 3 factorial into 7 factorial. So you can cut this 7 factorial, and if you solve this, yeah, this entire, simplify this entire equation, you will get 60 divided by 2, which is equal to, oh, I'm sorry. Um, okay. So the total won't be 60 here. The total will be 720. Okay. 720 divided by 6, which will come down to 120. Okay. So now, coming back to the question, if 3 items were taken out randomly from a bag containing 10 distinct items, there will be 120 different combinations that could be possible for this kind of situation. Okay. So I'm just, this is the answer on your screen. You can see it for a minute to understand, and then we'll move ahead to the next question. Okay. So the answer to this question is 120. Okay. Now let's move on to our second question. In how many ways can you arrange the letters in the word stats? That is STATS. Okay. I'll give you 2 minutes. You can try solving this question. Okay, so now we will start. Now let's see how this question is solved. So Again, now you will use the formula here for your probability and the combination formula that we have learned earlier. Okay. So in this case, if you see that the word that is given is stats. Okay. So the word here is stats. And the question is how many combinations are possible for this word stats. Okay. So now your n here will be 5 because if you count the number of letters in this word, it is 5. Okay. But the trick here is to see that your S word is repeated twice. Okay. And your T word is also repeated twice. So when you, if you go back to the question, how many ways you can arrange this letter? So this is the question of probability. So now if you calculate the probability for this, your probability of NR will be equal to N factorial upon your R factorial. Okay. So now you just put the values. So your n value is 5 factorial, and now your R here will be the number of repetitions that are happening for this kind of probability. So here there are two types of repetitions which are two in number. Okay. So your R factorial here will be 2 factorial into 2 factorial. So now you just have to solve this equation, which will be equal to 5 into 4 into 3 into 2 into 1, and upon 2 factorial is simply 2 into 1 and 2 into 1. Okay. So now you just calculate this. This 2 into 1 will get cancelled, and you can just calculate this by saying 60 by 2, and this is simply 30. Okay. So the answer to this question is 30. So I'm just leaving the answer on your screen for you to understand. Okay. So I hope this question was clear. And the answer to this question is 30. Okay, so the question was asked was how many ways you can arrange the letters in the word stats, and the answer is 30. You can arrange the this word 30 stats in 30 different kind of arrangement. Okay, so these were the two questions for your combination and probability. Now let's move on to our question number three, which is on your screen. 60% of individuals in a residential complex love dogs, and 40% of them love cats. 30% of individuals love both cats and dogs. What is the probability that a randomly selected individual loves cats given that they love dogs? Okay, your options are 0.3, 0.5, 0.4, and 0.6. I'll give you 2 minutes. If you know the answer, you can solve it. Okay, so now let's try to solve this question. It is a little tricky question, but uh, so to solve these kind of questions, you need to understand what the question exactly is asking. Okay, so now in this question, it is saying that 60% of the individuals love dogs, 40% of them love cats, and 30% love both cats and dogs. So now the question is asking about the probability of a randomly selected individual that will love cat given that they love dog. Okay, so that means they're trying to ask that if there are individuals who have, from all the individuals who love dogs, what is the probability of individuals from that they also love cats? Okay, this is the question asked. So now, when you solve these kind of questions, this is the formula that you use. So in this case, your probability of probability of suppose C is for cats and given that D is for dogs, then your probability of C will be of individuals loving the cat, and your probability of D will be your individuals loving dog. Okay, and your probability of individuals loving cat and dog, so that will be another probability. Okay, so this symbol is basically used to denote and. Okay, so now the question is asking how many of these who love dogs will also love cats. Okay, so now to calculate probability like this, you just need to um, calculate the probability of people which loves cat as well as dogs given that words, so any time these kind of questions are asked, if the question says given that, or the some kind of situation is already given, in that case the denominator, that value will come in the denominator. Okay, so here it is said that given the fraction of dogs, people who love dogs. Okay, so your probability of dogs will come in denominator. Now you simply just need to put the values. Your probability of people loving cat and dog is 0.30. It was 30%. Okay. Okay, I'll write it here. The probability of cat was 40%. The probability of people loving dog was 60%. And people loving both cat and dog was 30%. Okay. So it is zero point 0.3 divided by probability of people loving dog, which is 0.6. Okay. So if you solve this, the answer is 0.50. Okay. So 0.50 is the probability of people who loves cat while they also love dog. I'll leave the answer on your screen. So the answer will be 0.50. Okay, so now let's move on to our next question. Okay, so this was the answer to our previous question, which was zero point 0.5. And then moving on to our next question. A student tosses two fair dice. What is the probability that they both, so there are two parts in this question. First is what is the probability that they both will land on the even number, and what is the probability that the second dice will land on an even number if the first has already landed on an even number. Okay, so there are two parts to this question. I'll give you 2 minutes. You can try solving it. Okay, so let's try to solve this question. Okay, so let's just consider that the question said that there are two fair dices and we have to find the probability. Okay, so let's consider that probability of one fair dice is A and the probability of another fair dice is B. Okay, okay. So now the question was the first part of the question was that what is the probability that they both will land on even number? Okay, so now when so there are six sides of the dice. Okay, and out of this six sides, only three sides will have even number, right? So now simply to calculate the probability for A, your number of possible outcomes will be three, and your number of total outcomes will be six, which comes down to 1/2. Okay. And similarly, your probability for B of landing will also be 1/2. Okay. So now your question asks that both will land. Okay. So when this is the basic rule that when you talk about situations like this and this to happen, okay, in that case, you will multiply. Okay. So you will simply multiply the both the probabilities. So to calculate the probability of both of this happening will be 1/2 into 1/2, which is equal to 1/4. Okay. So the answer to your first part of the question, that what is the probability that two fair dices will land on even side, is 1/4. Now there was another question to it, that what is the probability of the second dice landing on even number if the first dice already landed on even number. Okay, so now again, this kind of question, it is asking about the probability of second dice landing on even number when the first dice has already landed on even number. Okay, so this is the question. So in that case, uh, again, you will use the concept of probability of A and B. Okay, upon. So again, this as I told you in the previous question, that when your question says that this has already happened or this situation has already happened, your denominator will be that situation. So in this case, the situation was that first dice has already landed. That was given. So your probability of first dice will come in the denominator. Now you simply put the values. Your probability of P of A and B is was 1/4, which we just calculated, and the probability of A will be 1/2. Okay. So if you solve this, your answer will be 1/2. Okay. So this is the answer to your second question. So the two parts of this question, first answer is 1/4 and second is 1/2. I'll leave the answer on the screen for you to understand, and then we can move ahead. Okay. So the answer was, as I told you, the answer was 1/2 and 1/4. Okay. So let's move on to our next question. According to the weather forecast, there is a 50% chance of rain. There is a 40% chance that you may have to step outside your house to fetch groceries. If the probability of it raining and you have to step outside is 30%, what is the probability that you will need to step outside when it is already raining? So it is a similar kind of question. I will give you 2 minutes. Please try to solve it. It's very simple. Okay, so let's try to solve this question. Again, it is simply the question of probability that we have previously learned. So let's just take two events. Okay. So your let your event A be event of raining. Okay. And let your event B be event of stepping outside. Okay. So in your question, the probability that was given for event A is 50%. For event B is 40%. Okay, so we'll just write that probability for event A is 50. Okay. For event B is 40%. Okay. And the chances of your A and B, it is 30%. Okay. So now again the question is asking that what is the probability that you will need to step outside when it is already raining. So when I told you previously in previous questions as well, when it is said that some event is already happening, and when the question is asked about that, that event's probability will go in the denominator to calculate these questions. Okay. So now to solve this, your probability of your event A and B happening together while your event A is already happening. Okay, because the question says that rain is already happening, and what is the probability of you stepping outside when the rain is already happening? So now you just put the values in this. So probability of A and B is 0.3, and the probability of A is 0.5. Okay, so the answer to this question is 3 by 5. It was a very simple question. Okay, so I'll just leave the answer on your screen so you can understand it. And then we'll move on to next question. Okay. So your answer to this question is 3 by 5. Now let's move on to next question. A survey on autoimmune disorders among children was conducted. The results are shown in the table below. Okay. So among female children, what is the probability that they are affected by an immune disorder? Again, it's a very simple question. I'll give you 2 minutes. You can try solving it. Okay, so let's try to solve this question. So again, the probability question. Um, so the question is asking about the probability of female childrens that are affected by the autoimmune disorder. Okay, so now if you count the total number of female students, it is 32 plus 8. Okay, so which is 40. Now to solve this question, again you take two events. Let's just call event A as being female. Okay, let's just call event A as female child and B as the event of happening autoimmune disorder. Okay, so the probability of female child getting affected by autoimmune disorder is your question. So now again it is using the same formula, probability of A and B happening, and because it is saying that female child having autoimmune disorder, this is already there. So in that case, your probability of B will be used here. So you simply have to put the values in the question. Your probability of A and B together is, if you see here, female and affected is 8. Okay, and total number of events is 40 here. So, okay, so I'm sorry, it was female, so it will be probability of A. So A and B together happening will be 8 upon 40. So that is 1 by 5, which is 0.2. Okay, so your answer to this question is 0.2. Okay, now let's move on to our next question. Which of the following can be represented by a discrete random variable? Your options are number of sweets eaten in a sitting, distance between home and workplace, speed of a car race, and the weight of students in a classroom. It's a theoretical question. Okay, so now understanding this question, so there are the different kinds of variables that are used in statistics. Four major kind. One is your discrete variable. So discrete variables are the ones that can be counted. Okay, so they will be whole numbers which can be counted. The continuous variables are the ones which are measured, and the values can range from different point values. Okay, so like your height, your weight, and the distance, these all are continuous variables. Then comes the categorical variables, which are also called as grouped variables, like gender. Okay, so female or male are the grouped. They are groups which represent multiple people in that group. So those are the grouped variables, also called as categorical variables. And the other one is ordinal variables. Ordinal variables, also called as the ranked variables, where uh, grades or levels about something is given. So the if we say that a person has got A grade or B grade or O grade, these kind of variables are ordinal variables. Okay. And when we talk about there are 49 girls and 48 boys in the class, then this 48 and 49 is the categorical value or a grouped value. Or suppose like these kind of these people are belong to A blood group or B blood group or AB blood group. So your A, B and AB are the categorical values or the group values. Okay, so these are the four major kind of variables. Now coming back to our question, there were four options. Number of sweets eaten in a sitting. Okay, so this is a countable value. So this comes under discrete variable. Okay, then the second is distance between home and workplace. So we already learned here that distance is a kind of a continuous variable. Okay, so the question was which of the variables are discrete? So your second option is wrong. Then it is the speed of a racing car. So again, speed is also measured as a continuous variable. So your third option is also wrong. Then comes the weight of the student. So again, height, weight, and distance, all three are continuous variables. So your fourth option is also wrong. Okay. So your correct option is number of sweets eaten in a sitting, and that will be counted as a discrete random variable. Okay. Now, question number 8. On rolling two fair dice, we obtain two independent variables, x and y. Calculate the probability of x being greater than 2 when y equals to 3. I'll give you 2 minutes. You can try solving it. Okay. So now let's try to understand this question. Okay. So your question says that there are two variables x and y. Okay. The important point is that both the variables are independent. Okay. So if we say that the variables are independent, that means x value is definitely not affected by the y value, right? X is not affected by y value. So this means that the two variables are independent. Now, the question said that the probability, okay. So the question said that the probability of x value being greater than 2 when your y value is equal to 3. Okay, so now let's first calculate that what is the probability of x being greater than 2. When we say that x being greater than 2, that means x could be either 3 or 4 or 5 or 6. Okay, so now why till 6? Because we are talking about a fair dice. Okay, so dice will have six values. So in that case, your total number of possibility is six here, right? So now when you talk about the two variables that is being asked, then we have the values as probability of x being equal to 3 plus probability of x being equal to 4 plus probability of x being equal to 5 and probability of x being equal to 6. Now, in previous question, we have discussed that when we are saying that there is some event, when we are using the word and, like this event and this event is happening, which we are saying denoting by this. Okay, so when event this and this are happening, we will always multiply the probability of these two variables. Okay, but when we are saying that this event or this event could happen, then in that case, you will always sum the values. Okay, so now here we are saying that the probability of x being greater than 2. So there are chances that x could be 3 or 4 or 5. We are using the word or here. Okay, so when we use the word or, we always sum up all the probability values. Now it's very easy to calculate. If you say the probability of x being equal to 3 in rolling a single dice, your x being equal to 3 will always be 1 by 6 value. Okay. Similarly, probability of x being 4 will be 1 by 6 plus x being 5 will be 1 by 6 plus x being 6 will also be 1 by 6. Okay. So now when you sum up all these values, you will get the answer as 4 by 6, which is 2 by 3. Okay. So now your answer to this question is 2 by 3, because your question was what is the probability of x being greater than 2 when y was okay. So now if you calculate this according to the previous formula, because these two variables are independent, in that case the rule will be that probability of x being greater than 2 will be equal to the probability of x being greater than 2 while y equals to 3. Okay, so this happens when the variables are independent, and that is why whatever value we are getting of this will be the answer of this. So the answer to this question is 2 by 3. Okay, so that is the answer to this question and the way to solve it. Okay, so now let's move on to our next question. Three cards are dealt from a well shuffled deck. What is the probability that among the cards dealt there is exactly one king? Well, I'll give you 2 minutes. You can try solving this question and then we can solve it. Okay. So this is your next question. Three cards are dealt from a well shuffled deck. What is the probability that among the cards dealt, there is exactly one king? Okay. So now let's try to solve this question. So this is a little tricky question and it's a little lengthy one. Okay. So now we will first calculate that what is the probability of dealing with picking up basically three random cards from an entire deck. Okay. So the question is asking first you need to calculate the combinations for it to calculate the probability of getting exactly one king in a cards where three cards are picked together. Okay. So you need to calculate different combinations for this. So first we will calculate a combination for when your n value is 52 and your events occurring is 3. Okay, so this is the combination where you calculate the total combinations that can happen when you pick three random cards out of an entire deck which is containing 52 cards. Okay, so now you just calculate it with the formula. Your c combination of c n and r will be equal to 52 factorial divided by 3 factorial into 52 minus 3 factorial. Okay, so if you solve this, your answer will be 132600 divided by 6, which is 22100. Okay, so now this is the combination of where this combination explains what is the what are the combinations that can happen when you pick three random cards from a deck of 52 cards. Okay, now now you need to check another combination that what is the combination chances that there is one single king. Okay, so out of all the kings that is present in a deck, what is the possibility that the card that is being picked out of four is a king? Okay, so now this is very simple. Here in this case, your n will be 4 because there are four kings in a deck of cards. Okay, and you are saying, and the question is saying that our value here will be 1 because you're picking one card out of the four kings, uh, four kings which is present in a deck of 52 cards. Okay, so now again using the same formula, we will calculate C for with n and r will be 4 factorial divided by 4 factorial into 4 minus 1 factorial. Okay, so now if you calculate this, your answer will be, oh, this one before, this will be 1 factorial. Okay, so your answer will be 4 into 3 factorial upon 1 into 3 factorial, and your answer will be 4. Okay, so of course, this was very logical that if you choose one king out of the four kings possibility in a deck of cards, of course, the probability of getting that one card as kings, combination which is possible will be 4. Okay, now we calculate the third combination. Now, the third combination will be that when you choose three cards, and your two cards have already been chosen because since the question is not asking about what is the probability or what is the combination of those two cards, the question is asking about the combination of the third card being the king. Okay, so now you have to calculate the combination that if two cards are already drawn, then what is the possibility of picking a card and that card being the king card. Okay, so in that case, your n will be 50. Now, why 50? Because the two cards have already been picked. So now the deck is of 50 cards only. So that is why the n value will be 50 here. Okay, and the R value will be 2 here because we are talking about the two cards. So your second combination is to choose one king out of four, and your third combination will be to choose two non-kings out of all the entire deck. Okay. So now to calculate this combination, again using the same formula, it will be 50 factorial upon 2 factorial into 50 minus 2 factorial. So now if you simply solve this, you will get answer as 1, 2, 2, 5. Okay. So now this is the third combination. Now, if now the question says that to get exactly one king, what is the number of combinations that is possible to get exactly one king? So for this, you will have to have two possibilities having together. Okay, one combination is this one, which says that the combination of getting a king out of the four kings of the deck, and the second one will be this one, okay, of choosing a two non-king cards out of the entire deck. So now if I'm saying that these two things should be happening together, that means the possibility of getting one single king will be this possibility and this possibility. So now, as I previously told, that when we are using two possibilities, then in that case the combination will be used by multiplying. Okay. So now for this, calculating this combination, your values will be 4 into 1, 2, 2, 5. And the answer to this is 4,900. Okay. Now, after calculating all these combinations, now finally to calculate the probability of getting the exactly one king in the three cards that you've picked from randomly from the deck. So now to calculate the probability, your formula is number of successful outcomes upon total number of outcomes. And this is here is the number of successful outcomes. Okay. So successful outcomes is 4,900 upon total number of outcomes you have calculated initially, which is 22100. Calculate this. Your answer will be 0.22. Okay, so the probability of getting one card as king out of three randomly picked cards from the deck is 0.22. Okay, I'm leaving the answer on the screen so you can see it, and then we can move on to the next question. Okay, so now let's move on to our next question. Assume a random discrete variable x, such as x lies between 0 and 3. Find the values of a given that p a probability of x being 0 is 1 by 9, probability of x being 1 is 4 by 9, probability of x being 2 is a, and probability of x being 3 is 3a. Your options are 1 by 9, 2 by 9, 1 by 3, and 4 by 9. I'll give you 2 minutes. You can try solving this question. Otherwise, I'll tell the answer. Okay, so let us try to solve this question. Now, the question says that there is a random discrete variable x, okay, and there are four different possibilities given for what the x can be, and you need to calculate the value. Okay, okay. So let's solve this. So now, if x is a random variable, then in that case, the summation of all the functions of x will be equal to 1. Okay, that means that all the probabilities that x variable can be will be equal to 1, which means that if we use all the probabilities given there, that is probability of x being 0. Now again, we are saying that the x could be this or this or this or this. Okay, so when we are using the word or, we will sum all the probabilities. Okay, so the probability of x being 0 or the probability of x being 1 or the probability of x being 2 or the probability of x being 3. Okay, so now summation of all these probabilities will be 1, right? Now we have the values for all the probabilities which are given here in the question itself. So probability of x being 0 is 1 by 9. Probability of x being 1 is 4 by 9. And then probability of x being 2 is a, and the probability of x being 3 is 3a. Okay, and the summation is 1. So now we simply have to solve this equation. So now if you solve this, this will be 5 by 9 plus 4a equals to 1. 4a equals to 1 minus 5 by 9. 4a will be equal to 4 by 9. So your a will be equal to 4 by 9, 51 by 4. Okay, so your answer is 1 by 9. Okay, I'll just leave the question on the screen. The, you can check how the answer has been solved to this question. Okay, so the answer to this question was that discrete variable. We had to find the value of a here, and the answer to this question is 1 by 9. Okay, so I hope these questions for today's session were about uh, probability and about combination, and they will be helpful for solving your assignments related to these, and of course, your exams. If there are any doubts or if there is anything else that needs to be discussed, you can write it in the chat box and we can discuss those questions in the next session. If not, we can end this session.